So I hope my presentation is visible. Kindly confirm once.
No, sir, not yet. Yes, not.
Is it visible, right?
Yes, sir. Yes, sir.
Okay. So good morning, everyone. Okay. So I am Dr. Ghanshyam S. Bugchi, Assistant Professor, NIT Tiruchirappalli. Uh, okay. So in today's workshop, I'm going to talk about threat modeling, attack trees, and how we can use the agentic AI pipeline to generate attack trees out of threat modeling report. Okay, so one of my PhD scholar, Mrs. Raj Lakshmi, she is working on to this topic. This is a genuine problem statement enterprises are facing in their day-to-day life. Okay, so being a security administrator, okay, you have to do a threat modeling of your enterprise organization. Okay, and you will get a threat modeling report which is a quite textual in nature and it is very too long to comprehend. As the security administrator don't have much time, okay, to read that report and get, okay, and to get idea about all the attacks which are quite possible onto the network, he needs some sort of visualization, and that visualization comes in the form of attack. Okay, so the objective is to generate the attack trees out of threat modeling report, okay, which is a kind of textual report. And how we can achieve this? Okay, so we can use the LLMs, large language models, or NLP pipeline, but there are some disadvantages are there. Okay, so we need to use agentic AI. I mean multiple AI agents we need to use for this purpose, because we need to consider the data from the different sources. Okay, so with this introduction, okay, let me go ahead. Okay, okay, so this is the outline of today's talk. Okay, so I will talk about the threat landscape. Okay, enterprise threat landscape, what does it mean? Then I will talk about threat modeling. Okay, how it can be done, what are the different types, and what are the different tools can be used. Threat modeling can be done in a different ways, so I will focus on the stride. Okay, stride based threat modeling. Then we'll discuss the attack trees. Okay, and then I will start. Okay, I will formulate a problem statement and how we can provide the solution for this problem statement using agentic AI, multi-agentic AI, and what could be the benefits of this. Okay, so when you look at the threat landscape of any enterprise organization, whether either it is a cyber physical system or typical IT network, when you look at the threat landscape, there are different things are there. So companies, organization having assets to protect. These assets can be privacy, files, account details, financial details, maybe the emails, their locations, or any other content. Okay, personal or organizational. Then you need to protect, you need to have your privacy, you need to maintain the anonymity, you need to protect your identity. Okay, these are all assets that you need to protect. Okay, you means maybe a organization need to protect all these things. So to protect these assets from different threats which are there, okay, so here I can say the cyber threats. Okay, there are different solutions are there. So to protect your anonymity, you can use the Tor browser, the Onion router, you can use the VPN access, you can have the VPN, you can have the multi-factor authentication, you can do the vulnerability patching, you can use the secured communication channels. Okay, you can have SSS. Different security solutions are there, okay, to protect these assets. Now, actually, who is endangering these assets? Who is having some sort of danger to these assets? So there are different types of threats are there, which are okay. So you can classify them as okay, phishing attacks, social networking, social engineering based attacks, maybe the rootkits, remote access trojans, malwares, maybe the mass surveillance program by the governments, okay, exploit kits, backdoors. So there are different threats are there, and basically these threats are backed by different adversaries, and these adversaries can be an individual person with a bad intention, or it can be a group of hackers, or can be a rogue government, or can be a law enforcement agency also. It could be ex-partner also, okay? So these are the adversaries. So basically, any person or the organization, they wanted to protect some assets. To protect those assets, they are having some security solutions, okay? And there are some different threats which are staged by different types of adversaries against these assets, okay? So it gives the complete threat landscape, okay? So when we talk about the cybersecurity, so basically we are going to protect the cyberspace, okay? So when I say cyberspace, I'm not talking about the entire cyberspace. I'm talking about my own personal cyberspace. It may belong to me, individual person, or it can belong to a company, okay? That cyberspace means it could be a critical infrastructure, okay, cyber physical system or industrial control system, or maybe a banking system, okay, BFSI sector, whatever it may be, or the IT sector. So this cybersecurity is all about protecting the cyberspace from different attacks, damages, misuse, and economic espionage or sabotage. Okay, so this is what it is. Now, next comes the threat modeling. Okay, so being a security administrator, suppose I am the in charge of an enterprise organization. Okay, I am responsible for securing that particular infrastructure. So what do I do basically, okay, to protect that? Because every day the n number of vulnerabilities are getting disclosed, those are getting exploited by the different threat actors, okay? And this threat landscape is highly dynamic, okay? It changes over time. So today, maybe the threat landscape or the exposure, okay, is less. Maybe it may be, I suppose some vulnerabilities got disclosed today. Because of that, this threat landscape may change over the time. It is highly dynamic. Okay, so it is not a static, it is changing over the time, all the time. So as it is, the threat landscape is changing all the time. Being a security administrator, we need to protect, proactively protect our network, our assets all the time from these attacks, even, okay, so growing of cyber attacks. So what do we do basically? The security administrator, they do the threat modeling of their cyberspace. Cyberspace may be their network infrastructure, okay? So this threat modeling can be done in a different ways. You can do the threat modeling per element, per device, or per interaction, okay? Because in cyberspace or enterprise organization, devices do communicate with each other using different protocols, different services. So you can go per device threat modeling, because within a device there are n number of software, there is a system software, there are n number of application or utility softwares are there, and some interaction happening between them. So you can do the per device threat modeling, or you can do, and you can also do the per interaction threat modeling, means these devices do communicate with each other using different services and protocols. So how the attacker can infect a one machine, and he can propagate, he can move laterally to other devices which are kept in an enterprise organization, and basically towards the critical resources which are mission critical or business critical. So overall, the threat modeling is basically a systematic process of identifying, analyzing, and mitigating potential security threats and vulnerabilities in a system or application, or you can call it as a network also, okay? One more, okay? So to the large extent, okay? So it's a process. So how does this process happen? So when we do the threat modeling, we could have some security objective. So for what we need to do first, so given the enterprise network, first we need to define, identify what data I need to protect. Because each and every data don't have the same level of, I can say, uh, importance, okay? So some data may be sensitive, some data may be super sensitive or critical, like that. Some data may be public, some data can be very private to the organization, something like that. So you need to identify the critical data and where it is located, okay? Means that where the data which is at rest, where it gets stored, and from where to where it is moving, okay? So you can have your security objective. Your goal is to secure that, okay? Then you can gather the information about your application information or the system information, network information. Then you come up with what could be the different adversaries who can pose danger to this data, okay? Do you identify those different threats? Then you analyze and prioritize those threats, okay? And based on that, you can define the mitigation. So it's highly impossible to mitigate all the threats, okay? It's not quite possible, okay? So administrator has to, prioritize some mitigations, okay? Not all, okay? He cannot fix all the threats, okay? Means he cannot do that. So he has to define some mitigations, and he has to document the entire threat model, and he has to validate, okay, and review. So he can apply some mitigations, he can validate and review it. And again, this cycle will be repeated again and again, okay? So it is kind of, I can say, kind of a spiral model which goes on, which can continuously goes on. So security administrator and his team continuously has to do this, okay? So they have to define security objective, they have to gather as much as information about their application softwares, system softwares, their network, the interactions. They have to identify, they have to assume some threats and the goals of those threats. Then they have to analyze, they have to do, so there will be some tools to do the threat modeling, and they have to define mitigations, and they have to document everything. So what are the benefits of this process, entire threat modeling process? Okay, so even before building the software itself, you can do the threat modeling, okay? So whatever the design level flaws will be there, those can be mitigated, okay? Those should not come in your application software or system software, okay? So you can do the secure software design, because if there is a design flaw in a software which is already implemented, it is very difficult to have the patch or fix for that. So for secure software design, you can have the threat modeling, you can do that. Even the software is developed or deployed, or the network for net, it is applicable to the application software, system software, and entire network also. You can do the risk assessment, okay? You can measure the probability of happening a particular attack onto your network, okay? That is one of the benefit of threat modeling. You can plan your security, your countermeasures in advance, proactive cyber defense. You can do that based on that understanding. And you can, in that way, you can do the compliance support. Means you can comply with any regulations which are there, okay? So whatever the regulations are there, compliances are there, you can PCI DSS or whatever the compliances are there, you can comply with that. For that, you have to regularly do the threat modeling. And by doing the threat modeling regularly, okay, or periodically, you can improve the security awareness among your staff, okay? So you will get to know exact the risk posture of your network. So there are multiple benefits of threat modeling. So when it comes to the threat modeling methodologies, there are different methodologies are there, okay? So the very first threat modeling methodology is a stride, where each character, so S stands for spoofing. Second one is a tampering, repudiation, information disclosure, denial of service, and elevation of privileges. So whatever attack you see on a typical enterprise organization, whatever attacks, basically each attacks uses some of this, things. Attack may use spoofing and tampering. Another attack may use the repudiation and information disclosure, something like that. Or in the worst case, a particular attack will do all of this, okay? There is another threat modeling methodology called as Linden, which is linkability, identifiability, non-repudiation, detectability, the disclosure of information, unawareness, and non-compliance. Basically, this Linden is applicable for the privacy-related threat model, okay, privacy. So the first one, STRIDE, is related for the typical cyber attacks which happens on organizations, okay, either IT or BFSI or the critical infrastructure. Whereas Linden threat modeling methodology is very specific related to the privacy. Okay, if you wanted to protect the privacy, banks have to have a lot of data about customers, and they need to protect their privacy. Even you can talk about the social media also. Okay, wherever these data centers are there, so they do the threat modeling, Linden threat modeling, in order to protect their privacies of their customers. There is another dread, okay, which is damage potential, reproducibility, exploitability, affected users, discoverability. There is another approach called dread. And one more is there called as PASTA, process for attack simulation and threat analysis. So you can simulate the attack. Okay, this is not red teaming based attack. These are the attack simulation. Maybe kind of cyber ranges. You might have heard about cyber ranges. You can simulate the attack on your environment or network, and you can do the threat analysis. Likewise, there are so many threat modeling methodologies are there. So for our work, we have considered the stride, okay, which is suitable for our network. Okay. Okay. So am I audible? Just kindly confirm. Then I can proceed with the stride. Is it audible now? Okay. 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 So
You can unmute. Okay, you can unmute
okay.
and talk.
No, sir. Is it audible?
Yes, yes. No, no, you are audible, but
Okay, okay,
yeah.
okay, fine, fine. No, no, sometimes there may be a problem. Okay.
No, no.
So when it comes to the stride threat modeling, the first is spoofing. Okay, for spoofing, why it violates the authenticity. So what the attacker does when he does the attack in your network, he may assume your IP address, system IP address, MAC address. Sometimes he or she may assume the stolen credential they will use. So they will spoof the data, okay, and they will use in the attack. Okay, that is about the stride. There is a spoofing. T stands for tampering. It violates the integrity of the data. Okay, another principle of the information security principle. Tampering violates the integrity principle of information security. Spoofing violates authenticity. Repudiation violates the non-repudiation principle. So normally, whatever actions the user or attacker did, they should not be in a position to deny from those actions. Okay. So repudiation violates the non-repudiation principle. There is another one, information disclosure. It violates the confidentiality principle. Okay. Okay. And there is another one, denial of service, which violates the availability principle of the information security. And the last one, elevation of privileges, it violates the authorization. So basically, in information security, we are having different security principles. Okay, CIA is the one, confidentiality, integrity, availability. Next two are authenticity and authorization and non-repudiation. So basically, in stride threat modeling, each of the this categories, spoofing, starting from spoofing to the elevation of privileges, each of them violates one of the security principles. Okay, that's one. So how do we do the stride threat modeling? So we have different tools available in order to do the stride threat modeling. Okay, so these are the some of the tools I have listed here. We can use the Microsoft threat modeling tool, which is quite popular. You can directly begin with that. You can do the OS threat dragon threat modeling. You can use EDS risk, SecuriCAD, 3Agile. You can use the PyTM, Python based. There are Python libraries, Python toolkits are available for Python threat modeling also. Okay, so there are different tools are there. So in this talk, I am going to talk about the Microsoft threat modeling tool, what we have used further to generate the threat modeling reports. Okay. Now, so this is all about the threat modeling. Okay, so we are going to do the stride threat modeling. Now, next comes the attack trees. Okay, so basically, the threat modeling tools will generate the threat modeling reports, which are quite textual, okay, in nature, and it will list n number of attacks. It will give you the different types of attacks. Okay, in different categories. In spoofing category, it will give the some attacks. In tampering category, for all those 6 categories, it will list out all potential attacks. Okay, Some of those attacks will really happen. Some of these attacks may not happen because in order for the attack to be successful, some condition has to be met. Okay. So at least it will tell what could be the potential attacks which can happen onto the network. Okay. So that hint, that idea you will get by doing the threat model. Next comes another terminology, attack trees. So basically these attack trees is the visual goal-centric diagrams that map out all potential methods an adversary can use to compromise the system. So when the attacker or the threat actor does the attack on your network, he will be having certain goals in his mind. He will be having some motivation for doing the attack. He or she may be behind the data. They want to steal your data or exploit the data, which is a kind of espionage. And this attack can be done by insider and outsiders also. Okay. The attack goal can be the sabotage also. Okay, maybe the encryption of data, maybe the deletion of data, or maybe locking of your devices. Okay, it can be in any form. Okay, so that completely depends on attacker's motivation. Okay, what he or she wants to do. So basically attack tree is a kind of visual representation. It shows the attack paths. It shows the attack path for a particular goal. Okay, for every goal there will be one attack tree. Okay, and that attack tree shows you how many ways that attack goal can be reached. Okay, so you can see in this diagram here, so there is a very well-known blog written by Bruce Kainer onto the attack tree. Okay, I have given the link here. So what you can, so here is one representative diagram. So attacker goal or the thief goal is to open a safe which is kept at house. Okay, so how he can do that? How that this robber, you can say, or the thief, how he can do that? So there are n number of ways are there to do that. Okay, so he can learn the combo key. Okay, okay, the combination of the keys he can learn by some means, and he can open a safe. But to learn the combo, he should know what is the combo. So the person who is operating a safe, he might have written that combo combination of keys somewhere. Okay, okay, he might have written. So the attacker may, or the thief may still he will get to know about that combo, and he can learn the combo and he can open the space a safe. Otherwise attacker can get the combo key from the target itself, the user. How he can do that? He can threaten the user. Okay, or he can blackmail by some means. Okay, or he can eavesdrop onto, or he can listen to the conversation of the person who set the combo key. Okay, and or he can bribe him. Okay, there are multiple scenarios are there. So to get the combo key from the target, means here target is the person who is operating the safe, he can do threaten, blackmail, eavesdrop, or bribe, and he can get to know the combo key. The other way, he can directly cut open the safe. He can go with some kind of machine and he can open it, but that is quite noticeable. Or what he can do, some supply chain itself, when they are procuring the safe, users are procuring the safe, he will come as an installation person. He will pretend as an installation person for the safe, and he will try to install the safe improperly. Okay, in such a way that in future, without the combination keys, the safe can be opened. Okay, or he can pick a lock, something. Okay, miss something. So this is just a representative example for attack for how the person, means here the robber or a thief, can open a safe. Okay, this is a simple generic example for you to I have kept for you, for all of you to make understand. Okay, so attack tree represents a goal, attacker's goal, and how many ways that attacker goal can be achieved. What are the different paths are there? Okay. So then once these paths will be given, okay, once all these paths are given to the security administrator, he can check, he can assign the values to these leaf nodes, and he can check compute the probability of happening each path. Means which one is the simple path or easiest path the thief can take, or which one is the hardest path. Okay, like that. First of all, if there are more number of paths are possible with higher probability, the unauthorized opening up, the probability of unauthorized opening of safe is very high. Okay, that is a risk assessment also. Then further it will give you the paths, probability of each path. Then you can have look at your security measures which are improperly placed, and you can place them properly, so that probability of happening of each path may get reduced drastically, and that will be in your favor. Okay, so all that thing you can do once you get the attack trees. One more thing, these attack trees here, you can have just the child nodes here, the last level, okay, the bottom level, listen to conversation, get target to state combo, something. Some of the sub goals can be met only when both the leaves are satisfied. There is an dependency. Means if attacker will get to know only conversation, but he is not able to get the combo key current state, he cannot open the safe. So both the things has to be fulfilled. That is AND dependency. Whereas for some of the path there is OR dependency. If you look at the top level, there is OR dependency. Okay, so means multiple paths are possible to open this safe in an unauthorized way. Okay, so this way this different metrics can be computed. What could be the cost of attack for each path? What could be the amount of resources required for each path? Okay, what could be the probability of attack? What could be the most resistant path? Something like that. You can do a lot of analysis on top of that, and you can you can rearrange, or you can redeploy or reconfigure your security devices in such a way that the probability of happening of each attack path is too high. Okay, in that way you can make your safe this you can stop thief to opening your safe in an unauthorized way. So why attack trees? There are, it can be used for risk visualization. You can do the risk analysis. You can do the root cause analysis also, why it happened, why this attack path is there, despite the deployment of security devices. Because security devices, you have to deploy at vantage points. If you did not deploy them consciously, it will lead to some attack paths. And you can plan your defensive strategy also. So there are n number of benefits of attack trees. So there are some key concepts. There will be a root node. Okay, there will be a some goals or sub goals. You will have child nodes, and there will be AND OR dependency between the node. Okay, OR and dependency. And how you can use, as I already discussed, what could be the use cases of these attack trees. You can visualize the potential cyber attacks in your network. You can visualize them. Whether they will happen or not, that is a secondary. But all potential attacks you can visualize. Based on that, you can do the risk assessment. Okay, you can measure the security posture of your network or a particular asset. You can propose some quantitative metrics, different types of quantitative metrics. You can do the security requirement analysis. Because when we develop the software or system or whatever it may be, our network, we are having certain security requirements. I'm not talking about functional requirements. I'm talking about security requirements, whether the functionalities are delivered in a secured way or not. So whether those security requirements are fulfilled or not, how you will get to know? By generating the attack tree for your system. Okay, if there are attack paths are there for a particular goal, means the security requirements are not completely fulfilled. Okay, and you need to rework onto that. You can do the vulnerability analysis. You can do the incident response planning. Okay, so what if you assume some attack happened here, how you can respond to that attack in order to protect the data or the services. Okay, that is incident response planning you can do once you got the attack tree. You can do the cybersecurity training and awareness also. You can train your staff, okay, about the potential attacks and how you can mitigate them. Okay, how you can plan your security, how you can plan your security solutions. You can do the compliance and security auditing also, because companies normally used to do the security auditing regularly. So you can generate the attack trees, and you can see if the less number of attack paths are there, minimal number of attack path means you are complying with the whatever the security standards or whatever the compliance standards are there, you are complying with that. And of course, these attack trees can also be used in penetration testing process, which the companies or the organizations normally used to do. Okay, so first they will generate the attack tree, and based on that they will see whether each of the attack path is really realizable or not. So it will help in penetration testing also. Okay, so this is all about the attack trees. Now let me come to the, okay, so we have seen threat modeling, we have seen the attack trees, essence of attack trees. Now I will start with this. So, okay, so here I am having some representative substation, one cyber physical environment I have taken. Okay, it is a kind of typical digital substation, okay, where you are having, it is a transmission substation, it is having different layers. Okay, so you are having different physical equipments in the digital substation. Okay, this is a kind of operational technology environment. And okay, so there will be some devices, we can call them intelligent electronic devices, and these devices are there, they collect the data, they do some decision making. If everything goes well, it's fine, but if something goes wrong, it will inform to another device, and that will take the some kind of action in real time. Okay, and there are some protocols are there, some sample value protocol, goose protocol, and ms protocol. So basically there are three different layers. Okay, there is a process layer, there is a bay layer, and there is a station layer. At the station layer we are having different windows based machines, and these windows based machines are for different purpose. For example, the engineering PC, what it used to do, there will be different configuration softwares will be there, and these configuration softwares will help in preparing different types of files, on top of which these digital substation works basically. And using engineering PC you can configure these IED devices or sensors. Okay, you are having SCADA and HMI computer, supervisory control and data acquisition computer, and you are having human machine interaction computer. There will be operators will be sitting, and they will be watching everything which is happening at this process and bay layer. Okay, it is a kind of you are acquiring the data from this layer, bottom layers, and you are visualizing that data. Okay, now there will be a gateway, another specialized device, industry grade specialized device, and using to this gateway there will be a control center will be connected. Okay, control center is a remote SCADA. There will be, we are having local SCADA through which we are watching what is happening at the bottom layers of digital substation. We can control also, have during commissioning or during the shutdown, we can commissioning of new devices, we can we can break the circuit, we can install the new devices, because you cannot go and switch off something here, because this is a high voltage transmission line is coming here. So you are having the dedicated devices to monitor and control these devices. Okay, but for that you have to pull all the data. So you are pulling the data to these devices, and you are sending the control signals. Okay, there will be another device. So this is a local monitoring and control setup, whereas you can have the control center. Okay, that may be at the remote place, maybe the different city, and from there also you can control these things, you can monitor and control. So how you can connect the control center to the gateway? Okay, to the substation via gateway. Okay, this is the point. Now suppose we wanted to do the threat modeling of different attacks onto this OT environment or cyber physical system environment. If I want to know what are the different attacks are possible onto these devices, okay, whether the bottom level devices or whether station level devices, I need to do the threat modeling. For that, I need to understand what are the data points, what are the data, different types of data which we need to protect at any cost. The data can be at rest, the data can be in transit also. We need to protect those data. We need to identify that. What are the softwares and services we need to protect at any cost? Those services should not go down, and the data tampering should not happen in between. Okay, so we need to identify all our goals, all security requirements which has to be fulfilled, that we need to identify. Then we have to consider again the interaction between the devices. Who is interacting with this computer? Is anyone using the USB drive? USB. Okay, is anyone is connecting these systems with the mobile phone in substation network, or is any vendor coming taking remote access of these computers? Okay, because these vendors supposed to configure the software sometimes. Okay, and any is there any remote access provision is there, or is there any VPN access provision is there? All those things we need to consider. How these devices can be accessed by different means. If you consider that, okay, so the device information, the connectivity between them, how the data flows, okay, like that, and what are the different trust levels. Okay, there will be different trust boundaries. So this will be one trust boundary. Okay, top layer, middle layer is another trust boundary, and third level will be another trust boundary. In each trust boundary, these devices trust each other. So once the attacker comes to this trust boundary, he can directly reach other devices also without any problem. Okay, using a lateral movement attack phase. Okay, so this is what the one setup I have given. Why I am telling this? Because this I am going to use. I am going to show some threat modeling report on top of this. Okay? So next, okay, why we are doing this? So there is another thing. Okay, so you might be aware about the MITRE attack framework. Okay, MITRE attack framework. That is a beautiful resource you can look at. This MITRE attack framework, they provide the techniques, and procedures for the well-known the cyber attacks which are reported. Okay, they provide the tactics, techniques, and the procedures. So I have listed here the tactics and techniques of typical ransomware attack in cyber physical environment. So you can have a look at that. The ransomware typically uses, okay, majority of these attack stages, not all. So first phase is the initial access, execution, persistence, okay, stealth, privilege escalation, evasion, how to fool the existing security controls, how to discover the data in connected computers to the victim computer which is already infected, how to move laterally to other computers, how to collect the data, how to contact with command and control server, how to exfiltrate the data, how to inhibit the response functions of OT environment, how to impair process control, and how to do the impact. So these are the typical attack tactics. These are the tactics. Okay, and under each tactic there will be techniques, and under each technique there will be a procedures which are technical stuff. Okay, so procedures can be different. Okay, so this way it happens. So you can have a look at that MITRE. Okay, so MITRE provides these tactics, techniques, and procedure for enterprise organization also. They provide these thing for the industrial control system or cyber physical system also, and they do provide for the mobile devices also. So three matrix they provide: tactics, techniques, and procedures they provide. Okay, why I'm talking about this? Because when we are generating the attack tree out of threat modeling report, we need to use this knowledge base which is already available. Okay, that's why I'm having discussion about this. Okay, so how to generate the threat modeling report? Let us come to the job. So we have used the Microsoft threat modeling tool, okay, to model the system. We model the system. Okay, so my Microsoft threat modeling tool is having a support for all the possible devices which you can have the enterprise and cyber physical system. Okay, you can design the canvas. You can use the Stride framework. Okay, in Stride framework 6, these attack categories comes. You can use them and you can generate the Word or PDF or HTML threat modeling report you can generate. So you can use the threat modeling tool, Microsoft threat modeling tool. Of course, you have to learn that. There is a learning curve. You can use that and you can do that. Okay, so there are beautiful videos available onto that. So you can do the threat modeling of your small network. Okay, so what we did a threat modeling for engineering PC. So we assume that engineering PC is very important computer in a digital substation, and it is connected to the intelligent electronic devices. Sometimes it connects with the SCADA and HMI computer, and sometimes this engineering PC is accessed by the vendors, okay, remotely. Okay, that provision is also there. So this, we wanted to do the threat modeling of engineering PC because there are some important project related files are there, substation specific files are there, some important data is there. We wanted to protect that. So we did a threat modeling for engineering PC. When you do the threat modeling for engineering PC, when we did, As I said, there are two types of threat modeling you can do. One is a per device, per element, per interaction. So here we have considered the per interaction threat modeling. So we have considered all the connectivities among the EPC and all the devices which are placed in a digital substation. Okay. And once you give this data, okay, of course you need a one template for also for that. So we have used smart grid threat modeling template, okay, for this. And we did the threat modeling for engineering PC. Okay, and we have assigned, okay, so once we did a threat modeling, we have defined hazards also. We have defined the impacts in terms of hazards. So hazard code 0 is the information disclosure. Hazard 1 is a human injury because it is a digital substation. If something goes wrong, there is a chances that human injury may happen, or there may be a equipment damage because these are power equipment. Okay, if something goes wrong there, it is a real-time system. Okay, so if something goes wrong, the equipments may damage, and your entire digital substation or at least one bay is gone. Because of that, there will be power outages will be there. Okay, in the particular area, and last one is a blackout, something like that. Okay, so we did a threat modeling, and once you give this, do this diagram, create a diagram, and when you provide all the parameters. So basically, for doing your threat modeling, you should know your entire system, all the devices, their interaction, and you have to place the trust boundaries out among them. So on top of them, so there will be trust boundaries. So each of the red box is a kind of dotted red box is a kind of trust boundary. Okay. So trust boundary means a device within a particular trust boundary, they trust each other. Okay, like that. So once you give this, it will generate a threat modeling report. Okay. So just see, this is a sample. I don't know whether it is visible or not. So it is kind of blurred. So it will give you some, it will list out the attack for each categories in the stride. For spoofing, it will list down the attacks, just like a replay attack. It comes under the category of spoofing. An attacker may attempt to intercept a message between engineering PC and the SCADA and resend it as a later time. So this is a very common attack which happens, replay attack, which happens in so many attacks. If you know the Stuxnet attack which happened on Iranian nuclear power plant, so basically attacker replayed the messages in order to fool this SCADA device. So what they did, they infected one of the computer, and what they did, they captured the original, the normal traffic, and they replayed the normal traffic over the time to the SCADA system, so that the operator who is watching the SCADA system, he thinks that everything is normal happening at the bay layer or in the OT environment. Okay. So there will be tampering attack, there will like that. There will be so many different types of attacks. So it will give at least some 50, 60 or 100 different types of attack it will give. Now question is, being an administrator, okay, I got to know different types of attack. Okay. But question is, it is a kind of textual document. Okay. It is a kind of textual document. It will take time to process or consume this document and take some remedial action, because on top of this, we have to do a lot of things. We have to do the risk assessment. We have to do the security planning or incident response planning. We have to do so many things we have to do on top of this. So it's very difficult to understand the report and do the other things which we have already planned. So this is a sample threat modeling report. You can see there are 87 attacks are there. Total 87 attacks are there. And each of the attack falls in any one of the categories, starting from spoofing, tampering, repudiation. So I have just attached the small portion of threat modeling report for your understanding. Okay. So of course, this threat modeling report is there. Okay. So once I will share, you can have a look at that entire threat modeling report. Now the question point is, we cannot, security administrator or his team cannot process, they cannot do much with this threat modeling report, because this is highly textual. Okay. So what we need, we want the attack freeze. We need some sort of visualization in order to do the remaining things what we have discussed. So we need to create the attack trees. Attack trees can be high level attack trees or can be low level attack trees. So as I said, we are considering the possibility of ransomware attack on substation. So what kind of ransomware attacks can happen onto the substation? Maybe crypto locker, maybe the locker, or maybe the wiper. Depends on what is the motivation of attacker. Motivation can be the espionage or maybe the sabotage. Espionage means the data stealing, and the sabotage means wiper and the uh, locker. Okay, that comes. So here, so attack tree has to be generated. Okay, so here I have listed the espionage, info stealer, sabotage. Okay, APT. In espionage, data can be leaked from the network. Okay, attacker can capture the traffic and he will get to know about the topology of your network and what are the services. The attack can be taken, the data can be stolen from the systems. Okay, again, when talk about the network, the network related information can be gathered using a passive reconnaissance. It can be gathered using active reconnaissance, right? Again, when you go at the detail, again the bottom level, you will come to know about all this spoofing, tampering, all those things. Okay, here in sabotage, system can be sabotage or network level equipment can be sabotage. So here the crypto locker, wiper, or locker can attack can happen, and here some data injection attacks or DOS level attacks can happen at the network level. Okay, so this is a high level attack tree. But basically, this high level attack tree will be made out of the low level attack trees. We wanted to have that attack tree. Now question is how we can get those attack trees. Okay, so as I said, there is a MITRE attack framework. Okay, so MITRE attack framework lists out the tactics, techniques, and procedures for the attacks, well-known attacks which are reported till date. So we will take that MITRE attack as a knowledge base. So what is the point? We are having a threat modeling report. We will have one agent to process this threat modeling report. We are having the MITRE knowledge base. We need the information from this one also. So we will take help of another agent which will extract some information out of this knowledge base, and that information will be given to our attack tree generation frame model. Okay, so we need multiple agents for that. Okay, so this is the snapshot of MITRE attack framework for industrial control systems. So you can have a look at that. So there will be a tactics which are in blue color. Under each tactic there will be a techniques, and under each technique there is a procedures will be there. So basically tactics talk about the how the attack can happen. No, sorry, why the attack can happen. Tactics talks about how the attack can happen, and some tactics talk about how a specific way this attack can happen. That is a technical stuff. Okay, so we need this because we want the attack trees for our network. We want to know how the replay attack can exactly happen, or how the locker or wiper attack on an EPC can exactly happen. What is the attack tree for that? So we need to use this knowledge base. Okay, so next comes to the problem. Okay, so we have seen the basics. Okay, different components. Now let's see the problem statement. Okay, so what happens? The generated threat modeling report is understand it's a time intensive process. So security analysts or administrator or their team has to manually read the threat modeling report, and they have to find out all the attack paths, which is quite time taking process. And there is not much automation happen for the attack tree generation for industrial control system or OT environment or operational technology domain. Another problem is that framework gap is there. There is a threat modeling report exists which generated a threat modeling report. Attack trees also exist, but there is no tool which can bridge the gap how to generate the threat modeling out of threat modeling report for ICS or OT environment. How we can generate the attack trees automatically. Okay, that gap is there. And if you go for simple LLM model, okay, to do this, you know about the LLM, they hallucinate. Okay, so if you take the generic LLMs, they may not give you ICS specific attack trees. They may give you the attack trees which are quite generic in nature. So even though you will generate the attack tree, you will never get to know how this particular attack specifically happen in our environment. Okay, so that is the problem. So we formulated a kind of research question for my PhD scholar. Okay, can an agentic AI pipeline automatically generate stride-aware industrial control system accurate attack trees from threat modeling report with no hallucination? Okay, can we do that? Okay, so this is a problem statement she come up with, and how we did that. So point is this. So the 4-question framework for threat modeling we did. So we are building the tree diagrams. So we want to pinpoint the threats exactly in a industrial control system, digital substation. And once we got pinpoint the threat, what we can do, we need to mitigate the threat. Okay, so we need to have the attack trees as accurate as we can. We need to have that. If you use the generic LLMs, the attack trees will not be specific for the industrial control system or the OT environment. Okay, and we need to validate those attack trees. We will try to imitate some of the attacks and we can validate that also. Okay, so this is what we can normally do. So so next comes the agentic AI. As I said clearly that we are going to use the agents. We cannot simply use one AI, one LLM for doing this work. So normally what the agentic AI does, so you all of you know about the AI, okay, artificial intelligence. So here what we will use, we'll use the agentic AI. So there will be a user interface when you are using the agentic AI. So user query, you can craft a user query, a kind of prompt you can give. And based on that prompt, you can make a plan, you can do some sort of planning. You can execute some actions with the tool, okay, tool chain. And it will give the results, some sort of results it will generate based on your query and the effective planning. If the result is not okay for you, it will be given as a feedback again to the planning phase, and the process will be repeated. So this iteration will happen, okay, from last phase to the first phase, like that. If results seems to be okay, definitely there will be a validation of some results, okay, based on what you are looking for. If it satisfy that validation criteria or validation metric, you can, that result can be taken as a response. Okay, so this is what the normally one agent, okay, agentic one agent does. So individually each of the agent works like this. Okay, this is a typical behavior. Next, what you can do, the responses coming from individual agents you can club together. Okay, and then you can basically you can solve the entire problem, whatever problem you are having. Okay, so what we are talking about, the multi-agentic AI. Okay, so we have seen how the one individual agent works, but here we are going to use the multi-agents. Okay, so multiple autonomous agents, what they can do, they can collaborate together, they can coordinate together, and they can solve a complex task. So here our task is, out of threat modeling report, we want to generate the attack trees. That is our task, right? So which is quite complex task. It's not like that, because we have to process the threat modeling report. We have to take some data from the knowledge base. There will be a attack tree generation engine will also be there. So we need the inputs from multiple sources, okay, like that. So of course the AI is involved in that, all of these tasks. Okay, so there are multiple autonomous agents are there. These agents can communicate, they can coordinate, and they can do some sort of reasoning. Why they come up with that reason, why they come up with that particular output, if you club with the explainable AI, they can reason about that, why they come up with that particular output or prompt or results, and they can act independently. Okay, so in order to do the job, their own job, they can act independently. And then they can, the results from the different agents can be combined in a particular engine, and you can solve your problem. So useful in dynamic and adversarial cybersecurity environment. Okay, so where basically it will be useful, dynamic and adversarial cybersecurity environment. As I said, the enterprise organizations are, it's a dynamic, because threat landscape is very dynamic. So today morning, till morning, my network was safe, but at 10 a.m. somebody disclosed a vulnerability, okay, and that is exploitable vulnerability. So suddenly it changes the threat landscape of my network. So disclosure of one vulnerability can change the security posture of your network. So for that, I need to do the threat modeling again. So threat modeling is not a one-time job. It is a repetitive task that you have to do based on external factors. If there are disclosure of vulnerabilities or something like that, then that you can do. If you are installing some new software services, or if you are giving the remote access to a external party, it changes the threat landscape. So before doing anything, you have to threat model that, and you have to be make sure that when you are going to do the changes, it should not violate the security requirement. If it is violating, then you have to be a bit conscious. Either you can drop the plan of doing the changes, or you can come up with some hardened way to do that. Okay, so for that you need to do the threat modeling. So that's why I'm saying you can use the multi-agentic AI, in highly dynamic and adversarial cybersecurity environment. So sometimes the internal factors, internal changes or external changes or factors, they make you forced to do the threat modeling again and again. That's why we needed some sort of automation to generate the attack trees. Why multi-agentic AI for cybersecurity? You can use this agentic AI because there are massive number of alerts are generated. Of course, it is not related to this project, but there is a multi-agentic AIs are heavily being used in security operation centers and intrusion detection systems. And the intrusion detection systems are, they are having one problem, which is they generate the massive volume of alerts. Okay, they can pull the lot of telemetric data from the devices, network devices or the core devices, and in order to process all of that, you cannot depend on the human being. You can have the agents. Okay, so AI agents you should have. Another thing, attack surface are distributed and continuously evolving. So the data what you are processing, it doesn't belong to a device. It is a distributed data. Data is coming from the different devices which are distributed throughout the network. Okay, so the data is a distributed nature, and it is continuously evolving. Okay, so the attack surface is continuously evolving. So as the data is distributed in nature, you cannot use the single model or single LLM to process that data. If you do that, there will be a chances that it will be overburdened or possibility of single point of failure. So you can use the kind of agents who can do some tasks, and they can give the refined results so that the final engine can process that and come up with the output what you are looking for. So single AI system normally struggles with scalability and specialization problem also. Scalability issue comes if you deploy only single AI system. And one single AI system, you cannot specialize for all things. You cannot do it for all. Okay, that's why we are going to deploy or use the multiple agents. So multiple AI agents are enable distributed intelligence, and you can have the adaptive defense using that. So all these points tells what is the essence of or significance of multi-agentic AI in this project. Okay. So we have compared why we need the multi-agentic AI here. So just see what the problem we are facing here. We're reading a long unstructured threat modeling report, which is in our case more than 4,000 plus word, or it could be bigger also. So here the threat modeling report I have shown only for engineering PC, whereas the similar threat modeling report we can generate for the gateway, we can generate from SCADA computer, HMI computer, even the intelligent electronic devices. So you can imagine what kind of the threat modeling reports, how many threat modeling reports will be there, and how much textual data will be there. So to process, to read the this structured threat modeling reports, we can have the separate agent. Okay, here my student, she has used the beautiful soup to extract, clean, and chunk the data. Okay, with proper length. Okay. Then another point in that threat modeling report, as we are this threat modeling is done from using a stride methodology. We need to identify all six different strategies, categories of the attacks. That can be done by using a LLM, okay, another LLM which can categorize or identify all the attacks in their relevant categories, okay, stride category. Then a goal is to generate one detailed attack tree per threat. For every threat which is there, we need to generate the attack tree, one attack tree for every threat reported in a threat modeling report. So what we can do, we can use some multi-space autonomous execution sequential LLM calls we can use, and there will be it will be without human intervention that will be done. Now, but the attack trees which has to be generated for ICS specific attack trees has to be generated, okay? So we need the domain specific attack trees. We don't want the generic attack trees because for industrial control system, we need the specific attack trees because the devices and the protocols what we are using, those are quite different, and even the data. So for that, we have to do the constraint reasoning. We need the ICS system prompt. We have to use the MITRE TTP knowledge base. Okay, for that, to get that, we need to have the separate LLM calls. And another problem is that, as I'm saying that this solution has to be tested, has to be deployed in industrial control system or cyber physical system, which are quite air gapped with the internet. They are quite air gapped. They are not connected with any other networks, including internet. So you cannot use any generic LLM which is connected to the system online, which is hosted on cloud environment, something like that. You cannot do that. Okay, so you cannot use something like some Jupyter notebook, something, or which makes the call in real time online. Okay, you cannot do that because by that means you are exposing again the substation to some other threats. Okay, so that you cannot do that. Recently, a lot of vulnerabilities are getting discovered in LLMs and GPT models also. If you are using them, your systems also get exposed to those, okay, like that. So what you can do, you cannot use the LLM which are so you have to make your custom built LLM. So what she did, she she have used Olama LLM, okay, Llama, some version, and it has to, this LLM, final LLM has to work in such a way that it should not have any external dependencies, okay? So some more constraints are there, okay? So as our objective is to generate the attack trees for the threat modeling reports for the cyber physical system, which is a digital substation here, and it is an air gapped environment, so we need to take care of all these things, okay? Now, so what we did, we have downloaded some knowledge bases, which are a lot of resources available on MITRE attack framework. We have downloaded all those knowledge bases and we process them using one of the agent, okay? So we compare with some other works also. There is a Stride GPT is there, which is proposed in the year 2023. It is a single LLM pass, but it is not a local LLM. It is a cloud-based LLM, and it does not consider the MITRE industrial control system tactics, techniques, and procedure. Okay, it is not for ICS domain. There is another one called Threat Forest. Okay, it uses the AWS environment, and again, so we cannot use the existing things. So what we did, we have developed our own Power Grid Threat Tree AI. Okay, one of the model we built, which uses the multiple agents, which uses the agentic AI, and which works on Stride, which generates the attack trees, and it is exclusively for the MITRE ICS, which can use for industrial control system. It's a local LLM. We don't have any external dependency, and it is a ICS domain specific. Okay. So this is what the architecture of architecture of this Power Grid threat tree AI. Okay. So here you can see at the layer 0. So at the layer 0, we are having all the threat modeling reports. Okay. So we are having the input layer. We are having all the threat modeling reports in HTML or HTML format. So for every device which are at the digital substation, engineering PC, SCADA, HMI, gateway, other substations, maybe the backup device, historian, a lot of devices are there. So you can have the per interaction threat modeling report for each of those devices. So there may be n number of threat modeling reports will be there. Of course, there will be separate effort you have to put in order to develop those reports, generate those reports. Okay, those reports will be input to, okay, so this second layer, layer one, which is document parser layer. So the document will be passed, these all these threat modeling reports will be passed using beautiful soup. Okay, okay, and it will pass the report, that is what, and it will generate some data. Again, in this threat modeling reports, we need to identify all the subsystems: SCADA, HMI, programmable logical controllers, engineering PC, whatever the devices, we need to identify each of those devices individually. Okay, and again, out of the same report, we need to identify the stride based attack things. Okay, selection detector, stride selection detector, identify the stride structure. Okay, so different attacks which are mapped to the different elements of stride, those we need to identify. So this is a document, this is some sort of document parsing, or you can call it a pre-processing. Okay, and post-processing, you can say these threat modeling reports are processed and passed here. And the whatever the output comes, okay, so here the different types of outputs, intermediate outputs, these models will generate. That will be agent given as an input to the another layer. This is stride threat extraction engine, which is basically LLM agent one, first agent. Okay, so it will extract the stride threats. So it will extract the all the uh, attacks. Okay, different attacks in different categories. Okay, spoofing, tampering, repudiation, information disclosure, and like this. Okay, it will extract that. Now, this agent one not only depends on the output of layer one, it again depends on the knowledge base also, which is the MITRE ATT&CK famous knowledge base. So see, this LLM agent one takes the input from the layer one and takes the input as a knowledge basis also. Okay, ICS, MITRE ATT&CK dictionary is there. A lot of resources are available. We can use those resources. We can download and use them. So this LLM agent takes two things, okay, two things as an input, and it does the job. The output of this LLM agent, it will create a threat list. It will create a threat list. What are the different types of threats? The complete description of threat. Okay, what is the attacker? Who is the attacker? What is his goal? How he can achieve his goal? That threat list will come. Okay, that threat list will be an input to the LLM agent 2, which is a layer 4, and it is a power grid tree or substation tree builder. Okay, it will kind of tree builder. Okay, attack tree builder. So you can have the specific set specific prompt you can construct. Okay, you can have threat list, you can have the stride description, you will have the relevant TTPs, all those things, because this LLM agent 2 also considers the MITRE knowledge base. Okay, that is the input, okay, to the LLM agent 2, and it generates the attack trees. Basically, it generates the attack trees. Okay, so LLM agent 1 does one job, LLM agent 2 does another job. Okay, of course they are not, they are working in a sequential fashion. Okay, so but in reality the agents supposed to work in a, they should work in concurrently in parallel. That happens if you are working on the agentic SOC, security operations center, or agentic IDS, intrusion detection system. But here at time t1 LLM agent will do the job, and at time t2 LLM agent 2 work, another agent does the job. Okay, so this is a kind of sequential pipeline. Okay, but in reality for other applications there will be a concurrent, multiple agents work concurrently. Okay, and they coordinate with each other. Once it is done, the layer 3, layer 5 will be the data visualization, and there will be a dashboard. Okay, okay, we can, to have the visualize the attack trees, we can have the dashboard, interactive HTML, so that we can interact with that. We can have the JSON export file, some JSON intermediate outputs in the form of JSON, and that JSON, these files will be kind of mapping with MITRE ATT&CK technique. Okay, so we are mapping each of the attack with the MITRE ATT&CK techniques also, because MITRE ATT&CK techniques are different. Stride is a different. Stride is a broad attack category, whereas the technique attack techniques are some specific techniques. Okay, so we can map that also. Okay, so we are doing the mapping between the stride and the MITRE ATT&CK techniques. and it will map that, and it will generate some kind of summary also. It will some summarize, and we can visualize the attack trees. So overall, in this particular architecture, we are having layer 5. First layer is input layer. Of course, before that, the all that threat modeling tools will be there, and that process is there, and human involvement is there. But this remaining pipeline from here to end, it is fully automated. Okay, so the security administrator and his team, they have to involve themselves in generating the threat modeling report. They have to give the specification of system, what they want to protect. Okay, what could be the goal of attacker, what they want to protect, what data matters for them, all that information they have to give. They have to come up with threat modeling report. But once the threat modeling reports are ready, what you can do, it will automatically generate all potential attack trees, ICS specific attack trees for your digital substation, and it will show you. Okay, so this is the way it happens. This is architecture design. Of course, there are some improvements need to be done, because I'm not saying this is not without limitations. There are some disadvantages and limitations also there. Those need to be addressed. Okay, so this is what the dashboard is. Okay, so this is a dashboard. So you can see the stride aware ICS attack tree analysis. This dashboard developed by my student. You can see the attacks, total attacks. Okay, how many attack paths are there overall. Okay, so you can see that how many attacks are critical and high, how many total threats are there, 48, how many attack trees are generated, total 48. In all these 48 attack trees, there are 144 attack paths are there. And again, what are the potential mitigation? It suggests some potential mitigation also. So how many 216 attack industrial control system controls it is suggesting. Okay, and some more things are there. So these all of these attack trees are listed here. So just see spoofing RTU or programmable logical controller identity on Modbus network. Modbus is a protocol. Okay, so for this there is a dedicated attack tree. It can be done, means this attack in this for our substation network, how it can be done. So there are 3 attack paths. Okay, so goal is to spoof RTU or PLC identity on Modbus network. How it can be done? It can be done in a first way. This is a first attack path. There is a second attack path, and there is third attack path. Means this attacker can achieve his or her goal in 3 ways. Now, when you talk about the first way, there is again end dependency between the leaf nodes. Means to achieve the first attack path, you have to realize the first attack path. Attacker has to do both the thing. Attacker has to do the both thing. What is that? Attacker must get some physical access to the Modbus. Okay, Modbus. He should have the physical access. Or attacker, physical in the sense attacker should not be there physically. Attacker designed malware must be there onto the network somewhere. Okay, and then what that malware does, or advanced persistent does, it sends the false data to the SCADA or HMI using replay attack, something like that. Okay, so this way it can be realized. Likewise, the second attack path can be realized, and third attack path can be realized. Of course, some fine tuning of this is further required, because we are testing different LLM. She has used the Olama model. There are some others are also there. We are testing with that, and again we are fine tuning them based on the ICS specific data. Okay, so these are the outputs we got. Likewise, for the second attack tree, we got for the second attack, we got some attack tree. Second attack for individual attack, you got the different attack trees. So this is another attack tree for the EPC. Okay, this is another attack tree for the SCADA. Okay, exfiltrate SCADA or historian data from the to reveal the grid. From the SCADA computer, attacker can exfiltrate the data. That is a kind of I can say kind of eavesdropping based attack, or you can say kind of it's not a sabotage, it's a data exfiltration or information stealer. So you can see each of the attacks visually instead of going through the threat modeling report, which is a quite textual document. You can see each of these attacks visually. Okay, you can see that. Okay, likewise for other attacks also, I have taken some representative examples here. Now question is what we can do with these trees. Question is, once these attack trees are generated and shown to the defense team or the security administrator or analyst team, what they can do, they can do the, they can see, they can do the risk modeling, okay, risk analysis. They can attach some values, some probability scores they can attach to the leaf nodes, and they can compute the overall risk score for this particular goal. What is the probability of you know, this security requirement violation? Okay, so this is because administrator has to, you know, insist or ensure this security requirement is fully implemented. But if it is not implemented, then what are the chances of attack? What is the probability of this is happening in our network? They can calculate for each of the attack tree. And for each of the attack tree it is computed, you can compute it for your overall digital substation also. Okay, that you can do. That macro level risk assessment can also do. I'm talking about micro level risk assessment. You can do it for individual attack tree. If you attach the cost, attack cost to each of the leaf node, you will get to know which path is more difficult to realize, which path is more difficult to realize. Okay, so that if a particular path is more difficult to realize by the attacker, you can focus your defenses on the less resistant path, the path which poses the less resistance to the attacker. Because your security solution may not cover all the attack paths. It's highly impossible. You cannot make your network 100% secure. That is impossible task to achieve. But at least what you can do, these security paths which are already somewhat more resistant, you can focus on the attack paths which are less resistant, which are likely to be taken, which are easiest attack paths, and you can make more resistant. Okay, that you can do. Okay, so a lot of risk analysis you can do. You can do the post incident analysis. If the incident happened, what remedial action you can do. You can you will get to know whether your security countermeasure security solutions are properly placed or not. If they are not properly placed, if they are not able to cover these attack paths, you can place them in a particular vantage point in such a way that all these attack paths will be covered by those security solutions, maybe the firewall or intrusion detection system, whatever it may be, that you can do. Okay, so a lot of things you can do. Even it will be helpful for the penetration testing team also. If you are doing the penetration testing of your network, okay, it is a kind of red teaming you are doing. If your in-house team is doing the penetration testing, how do you know that how to do the pen testing? How do you know? There must be some sort of guidance. So you can generate the attack trees. You can generate these attack trees, and these attack tree will help them as guidance. So it will tell them, okay, do this first, do that first. If all these things are realized, these two leaf nodes are realized, automatically the sub goal is realized. If sub goal is realized, automatically the goal is realized. So they can say that, oh yes, this attack is really possible. This attack is really possible. Means in future somebody can take this path and can violate our security requirement. So it will be kind of guide for the penetration testing team. So there are different things. Another thing is, you might be aware about the cyber deception. You can deploy the different deceptive artifacts throughout the network. The ultimate goal of deceptive artifact is to slow down the attacker, misguide the attacker, distract him, slow him down, so that you will get, your defense team will get a lot of time to react, because it is a race against time to protect your resources. Once the attack happens, it will be very quick. So how you can delay the attack? By deploying the various deceptive artifacts in a network. But question is, where you can deploy those deceptive artifacts? Honey file, honey tokens, honey pot, honey net, honey device, honey credentials, honey words, different deceptive artifacts are there. Question is, you have to deploy them at the proper vantage point. How you can deploy them? How do you know that? So these attack trees will tell you that, okay, this attack is happening this way. So some deceptive artifacts can be deployed here. If you are not able to harden one of the attack path, because if you are going to harden one of the attack path, if you are doing the security hardening, chances that service may go down. You have to bring down that service temporarily down. It will affect your business. Okay, it will affect the availability of service, and it may affect your business or whatever it may be, or operations. So what you can do in such situation, onto that path, attack path, you can deploy the deceptive artifact so that if the attacker takes that path, he will get distracted towards the deceptive artifacts and he or she will reveal his presence. So first goal is to distract the attacker, okay, along the path, slow him down, waste his effort, drain his energy and resources, detect his presence, like that. So proactive and reactive. Even though attacker may succeed in stealing the data, you plant some fake data here and there. So when he steals the data, he might be stealing the fake data also, which is quite similar in nature to the original data. So once he steals the data, he will never get to know why which data is really correct and which data is not correct. So even after the successful data breach, attacker cannot easily exploit or misuse that data, okay, or attacker cannot sell that data in a dark net because it's a trust issue for them. Okay, so likewise it will help you in planning the deceptive artifacts also. That is a passive deception. You can do the adaptive deception also. It connects with the game theory. By looking at the attacker behavior, attacker move, you can deploy the deceptive artifacts in real time also. You can proactively deploy, and you can, in response to the attacker move or action, you can deploy the deceptive artifact. That is an adaptive cyber deception. That also you can do. Okay, that is a kind of game theory. Okay, so kind of Nash equilibrium. Okay, so zero sum game. So different things can be done with the help of these attack trees. Okay, so let me come to a conclusion. Okay, so we have built an agentic AI pipeline which can autonomously transform these tried threat modeling reports into ICS accurate attack trees entirely on local LLM. Okay, so because we cannot use the existing LLMs, we have to have a dedicated LLM which can be fine-tuned. The key features of this are it is a first tried aware attack tree generator for industrial control system. It is having 6 pass extraction with full document processing. Okay, it is air gapped, means we can use it for OT environment and as we are leveraging the local LLM. Okay, and there are multiple agents are there. Of course, they are sequentially arranged. Again, some improvements we are planning to do is we are planning to put some logs. Okay, even we are planning to consider some logs in real time and the events also in the real time. Another agent can be used for that, which is continuously sending the data to our engine. And we are mapping, not only we are generating the attack trees, we are mapping the attacks to the MITRE tactics and techniques. Okay, this is what we are doing. So here we reach the end of our presentation. Okay, so this is the first work we did. Okay, and it is very relevant work, and there is a key role played by the agentic AI here. Okay, without agentic AI, it is not possible to achieve this. Okay, so here I reach the end of the my presentation. If any questions are there, I can take those questions.
Yes, any questions from audience side?
Sir, if we build a multi-agent system, can we make the most of the agents by ourselves, like fine-tune the low-level LLMs and then use them, and
Yes,
keep one
yeah.
high agentic AI system on the top? Because again, the same thing, the token issue is the problem. So can we just keep the main administrator AI, means the one who coordinates with all the other smaller agents, as the one who uses tokens, and the rest can we just fine tune the low level LLMs which do not require tokens or are open source, or make our own, make our own small scale LLMs for these by training them?
Yes, that's quite possible. That's what she is doing. Because our first requirement here is we cannot use the LLMs which are available over out there. Because by
Exactly.
doing that, we are exposing ourselves to that. So we want our own local LLM to be trained. Once you train that local LLM, you can fine tune, you can use as an agent. Okay, that you can do. And there will be some master agent who can pull the data from all of these agents which are distributed here and there throughout your network for any purpose, and in that way you can save the tokens. That's quite possible. That's not a big deal. That's possible.
Exactly. Okay,
Yes,
sir. Okay, thank you. That's what I was thinking of doing.
it's possible.
Okay.
Any other questions? Okay, so I'll share the mail ID and contact details of Ghanshyam sir. Anyone can contact directly to them if you want to work with.
Yeah. So one kind of thing I would like to say, if anyone is, there is a lot much can be explored. I'm not saying this is the very first work of my student. She just started. There's a lot of ideas are there. A lot of things can be done. If anyone interested to take it further, we are open for the collaboration, provided you put some effort and work with us. Okay, so anyone interested, you can contact me, you can write a mail to me.
Dedicated effort is required because last time also few students has interested, but after
Exactly.
working 1 month then left.
Yes, yes,
So not
yes,
like that. Means you have to stay for 5 to 6 months. You have that much dedication, interest. So that sir is going to give their time, his time. So you have to also give your time and interest. Then only work can be done.
okay. So I would like to acknowledge my PhD scholar here. Actually, she did all this work, and she only prepared the presentation.
No, no, very new things,
So
very
yes,
informative one.
yes, yes, yes.
Thank you, sir. I'll be on touch with you and touch with
Sure,
you
sure, sure, sure.
and share your.
Thank you all. Thank you all.
Thank you, sir. Thank you very much, sir.
Thank you very much.